All right, so welcome back to part 2 of our chapter 4, essentially, simplex method. We're working on solving more complicated problems. We're going to be using that, what is it? Oh yes, the simplex method, but we don't do it by hand because that would be silly. We use some sort of technology to solve it. All right, so here's our example we're going to be working on now. This is number 32. I don't know what that means. I just stole it out of the book. So it's number 32. A manufacturer of bicycle builds racing, touring, and mountain models. So racing bikes, touring bikes, and mountain bikes. The bicycles are made of both aluminum and steel. The company has 91,800 units of steel and 42,000 units of aluminum. The racing and touring and mountains need 17, 27, and 34 units of steel and 12, 21, and 15 units of aluminum respectively. How many of each type of bike should be made in order to maximize profit? If the company makes $8 per racing bike, $12 per touring bike, and $22 per mountain bike. Those seem like really low numbers, but okay. Let's get started. First things first, identify our variables. It looks like there are 3 variables, so I'm going to call those 3 variables our x sub 1, which will be the number of racing bikes. X sub 2 will be the number of touring. And then x sub 3 will be the number of mountain bikes. Okay, and it looks like our limitations, our restrictions, are going to be the steel and the aluminum. And then our objective is going to be to maximize profit. All right? So I'll do the objective function first. Our objective function. Our objective is to maximize profit. My objective function is going to be z equals the profit I make. So it's $8 times the number of racing bikes plus $12 times the number of touring bikes and 22 times the number of mountain bikes. And then I need some constraints. My restrictions, my constraints. Let's see, my constraints are going to be, what is it going to be? It's going to be 17 units of steel for every touring bike, plus 27 units of steel for every, racing and then touring, and then 34 units of steel for every mountain bike, and we cannot exceed 91,800 units of steel total. And then we have the aluminum, 12, 21, 15, and we cannot exceed 42,000. X1, X2, and X3, the non-negative condition, because we can't make a negative number of bikes. So it looks like we've got a standard maximization problem. These are less than or equal to's. We're maximizing an objective function, and our non-negative condition applies. So we would use the simplex method. Right. So I'm going to go ahead and grab that website. I have 3 decision variables, and I have 2 constraints. This is a maximization. I don't remember the numbers, so I'm going to go back and grab them real quick. 8, 12, 22. 8, 12, 22. And I don't remember my constraints, so I'll go back and grab those. My first constraint is 17, 27, 34, 91,800. 17, 27, 34, 91,800. And my second constraint, I'll go back and take a look at 12, 21, 15, 42,000. 12, 21, 15, 42,000. So I have my, okay. And I get my solution. I get my solution is 0, 0, 2700. So my solution is that x1 should be 0, x2 should be 0, and x3 should be 2700. Okay. And what's our maximum profit going to be? 59,400. So we should make 0 racing and touring, 2700 mountain, bikes for 57 and change, $59,400 profit. All right. Now, one of the questions that might be asked is there any slack in your system? Now, slack here, because we have two constraints, would be represented by two slack variables. That would be an S1 and an S2. So if they were asking you about S1, that would be our slack for our first constraint, and S2 would be our slack for our second constraint. Now, if I needed to know the value of those slack variables, I could find it by taking this final solution, putting it back into that inequality and see if there's any leftover goods, because that's what slack would mean. For example, I don't know what S1 is, but let's say S1 was 1,000. That would mean that there was 1,000 units of steel that we didn't use. Or if S2 was 500, there'd be 500 units of aluminum. So what is the value of S1? Well, S1 is going to be 91,800 minus all the steel, right? Steel? Yeah. Used. Now, since x sub 1 is 0 and x sub 2 is 0, all the steel used is just going to be 34 mountain bikes at, 34 pounds per mountain bike, or 34 units, whatever units are, times the 2,700 that were used. So I'll go over here and grab my calculator, and 91,800 minus 34 units times 2,700, and I get 0, and so that means that there's no slack in the first inequality, or we used all of the steel available. Now I can do the same thing to find S2. Okay. S2 will just be 42,000 minus the used aluminum, right? But the used aluminum, since the X1 and the X2 are both 0, is just going to be 15 times 2,700. So 42,000, missing a 0 here, minus 15 times 2,700, and I get 1,500. So what does that mean, that my slack 2 is 1,500? Well, that means that there was leftover materials in our second constraint, or there are 1,500 units of aluminum not used. So the slack variables, although they seem kind of silly when you're setting up these simplex tableaus, in the end, the value of the slack variable actually has meaning. The value of the slack variable tells us what's left over when we run this scenario. So we're still going to maximize our profit. We just got some leftover materials in the end. We ordered too much, you could make that argument. Or many other ways to think about it. It just simply means that maximizing profit doesn't mean you used up all your raw materials. It just means you maximize profit. In this case, we used all our steel. We just have a little bit of aluminum left over. Okay. Let's try it again with the Cut Right company making productions of knives here. Right? All right, so I've got the Cut Right Company, sells knives, sells sets of kitchen knives. Let's see. All right, so they sell kitchen knives. The basic set consists of 2 utility, 1 chef's. The regular set consists of 2 utility, 1 chef's, and 1 slicer. Deluxe set consists of 3 utility, 1 chef, 1 slicer. Their profit is $30 from a basic, $40 from a regular, and $60 from a deluxe. The factory has on hand 800 utility, 400 chefs, and 200 slicers. Assuming that all sets will be sold, how many of each type should be produced in order to maximize profit, and what is that maximum profit? All right, so variables. It looks like we had 3 variables, our x1, our x2, and our x3. Our x1 we're going to call the number of basic sets. Our x2 is going to be the number of regular sets. Ooh. And x3 is going to be the number of deluxe sets. We have an objective. Our objective here, so our objective function is to maximize profit. Our equation for that, we're going to call that Z, is going to be our profit equation. So we make $30 for every basic set. We make $40 for every regular set, and $60 for every deluxe set, and there's our objective function. Now we need some constraints. Well, it looks like the constraints are how many of the different types of individual knives we have. For example, a basic set requires 2 utility knives. So 2 utility knives times the number of basic sets. Our regular set consists of 2 utility knives. And our deluxe set consists of 3 utility knives. And I know that I can't use more than the 800 utility knives I have on hand. So my first inequality is the utility knife inequality. So my first slack variable, if I go there, would be how many utility knives are left over after I make all my sets of knives. I have another constraint, a second constraint for my, the chef's knives, right? A basic set contains 1 chef knife, so 1 times the number of basic sets, plus a regular set has 1 chef's knife, and a deluxe set has 1 chef's knife, and I only have 400 chef knives on hand. And so my S2, my slack 2, would be the number of chef's knives that we don't use. Right? And then we got our deluxe is going to have a slicer, and the regular has a slicer, right? But the basic set doesn't have any slicers. So 0 slicers times the number of basic sets plus 1 slicer times the number of regular sets plus 1 slicer times the number of deluxe sets. And we cannot exceed the 200 slicers that we have on hand. And then, of course, this is going to be here. The x sub 1, the x sub 2, and the x sub 3 all must be greater than or equal to 0. So I've got an objective function. I've got less than or equal to constraints, and I've got non-negative conditions. It looks like I've got a standard maximization problem, so I can go ahead and use that simplex technique. So I'll click Start up there in the upper left to restart. There are 3 decision variables, and there are 3 constraints. I'm going to maximize it, and I believe, if I remember correctly, it was $30, $40, and $60. And it was 2 and 2 and 3 and 800 for our utility knives. And then it was 1 and 1 and 1 was less than or equal to, I want to say 400. I'm going to check. Yep, 400 for our chef's knives, and then it was 0 and 1 and 1 and less than or equal to 200 for our slicers. And so I'm going to check everything over. This is going to be the weak point, is where I'm putting things in. I could make that mistake, so I want to check that twice and then get me to a solution, and it's 100, 0, 200. So I'll go back over here, and so my solution mathematically is x1 is 100, x2 is 0, x3 is 200. I'm just going to go back and check to make sure I got that right. 100, 0, and 15,000 for z. And z is going to be equal to 15,000. And so how do I interpret that? Well, we should make or produce, or whatever word you want to use there, 100 basic sets, 0 regular sets, and 200 deluxe sets. Okay. Now, what about those slack variables? Does S1 have any value? Well, let's check and see. If I take this solution and put it back into that first constraint, I have a 200, a 0, and a 600, and that's exactly equal to 800. So my S1 is 0, meaning that we used up all of our, what was S1? Oh, that was right. That first one was our utility knives. We used all the utility knives. Okay. What about S2? Is there any meaning or any value to S2? Okay. Again, I'm going to take that and put it now into the second equation. So I have 100 plus 200. Ooh, S2 is equal to 100. There's 100 left over. And what was S2? That was our chef's knives. So we still have 100 chef's knives. We have 100 chef's knives left over. Okay. And then what about S3? Does S3 have any value? So S3 is to put that solution into that third inequality, and so it's exactly equal to 200, because remember the 100 goes in the x1, so 0 times 100 is 0. So 1 times 0 plus 1 times 200 is 200, so that's equal to 0, meaning that we used up all of our chef's knives. I'm sorry, our slicers. So it looks like we should make 100 basic sets, 0 regular sets, 200 deluxe sets. Our profit will be $15,000. That's this right here, remember the z value. And we have 100 knives left over, or if you want to think of it in terms of slack, the slack for the second inequality, as we have them written there, is 100, or S2 is equal to 100. This puts us at 18 minutes. I still have two more examples to do, so I'll come back and do those in a third video. I'll see you back here for that.